hopefully that'll clarify any misconceptions that you have with derivative. And then I'm going to start the review worksheet with you. There's just some things that I want to kind of highlight on the review worksheet. It is due on Tuesday next week, so we'll have today to work on it and sometime in class on Monday to work on it as well. But it's one review worksheet for Tuesday's test. And again, it's due on Tuesday. So I will go through and kind of like, I know what questions students ask, and I want to make sure to kind of give you a heads up on what the question is asking for. What does it mean? What does it represent? To make it a little easier on you to kind of work through those problems. So if you look at your homework, the last book assignment from yesterday, and yes, if you want to bring your books in on Monday, you can. Tuesday, Wednesday. If your name is in your book, because I don't have that stuff kind of filled out or pulled up and ready to go yet. Yeah, that would be great, because otherwise I'm not going to know who it belongs to. So questions 31 and 37 were the two that I wanted to kind of talk about. There was also 31 was also similar to a question on page 799 as well. So, or not 31, 35, 33 was similar to one of the questions on 799. So I thought we would look at 33 and 37 and kind of see what they were talking about. And I can't write the correct number. There we go. So number 33 says f of x equals 5. And the directions say to find the derivative of the function. And in most cases, to find the derivative, you need to find the limit as h approaches 0 of f of x plus h minus f of x all over h. That's the process of finding the derivative. It's the process of finding the slope formula of the tangent line. However, in number 33, your equation or your function is just f of x equals 5. There is no place for you to take f of x plus h and replace x in there because there's not an x. It's just f of x equals 5. What kind of line would you have if f of x is equal to 5, Peter? Horizontal line. So it's a horizontal line at y equals 5. Always horizontal, forever. The derivative of a function is derived from the original function, but the derivative also means something else. Peter, what else does the derivative mean that you're finding? What else does the derivative mean that you're finding, Hannah? It is the slope. So finding the derivative is also finding the slope. They mean the same thing. So in question number 33, you cannot use the formula for the derivative because you can't really plug an x plus h into the problem. But if you understand that the derivative, finding the derivative is also finding the slope, you know, what is the slope of a horizontal line? 0. So the slope of a horizontal line is 0. So my slope is 0. Therefore, the derivative is 0. So if you looked in the back of the book and you saw that answer, which I also have up here because I took a screenshot of my book, the answer is 0 because the derivative is also the slope. Those two words are interchangeable, and the slope of the horizontal line is 0. Questions with that? So that's why it's 0. If you're like, how do you get that 0? So horizontal line has a slope of 0. The derivative means slope, so the slope of that line is 0. The other one I wanted to talk about was 37, because this one has 1 over x squared. It's a fraction, and not only is it a fraction, but you have a squared term in the denominator of the fraction. And again, the directions are the same thing. It says find the derivative. So we're looking at 1 over x squared. In this case, we will use that limits process to find the derivative. So the limit as h approaches 0. So we're supposed to have f of x plus h. So 1 over x plus h squared. That's my f of x plus h. Then I'm supposed to subtract f of x. Well, I'm subtracting 1 over x squared. And all of that's over h. So that's what my first step should look like. 1 over x plus h squared, f of x plus h. 1 over x squared minus f of x all over h. Now, when you have fractions, in order to combine those two fractions together, Darby, what do you have to do to take those two quantities and subtract them? So when you do that, keep the denominator as a factored form. Don't FOIL or distribute or do anything with the x squared and the x plus h squared. And that's pretty much consistent whenever you find least common denominators. The least common denominator you just keep as a factored form, because the hope is that something might cancel from that eventually. The numerator, though, our goal is to combine those numerators because I have a subtraction and I want to try and subtract the terms from the numerator. So we do need to FOIL the numerator. So we have the limit as h approaches 0. The first one is x squared. The second one, x squared plus 2xh plus h squared. That's what x plus h squared is. But all of that's being subtracted because that second fraction is being subtracted. So then I have a minus x squared, a minus 2xh, and a minus h squared. So that's your numerator. The x squared from the first one, you're subtracting that quantity x plus h squared. So once you FOIL it, all of it needs to get subtracted. Then keeping the denominator factored. The least common denominator was the x squared and the quantity x plus h squared. And then all of that is still over just that lonely h sitting on the bottom. So, Darby, what happens after we do some FOILing? What can we do next? So let's see here. And then in that same step, Darby, if you are dividing the entire top fraction by h, yeah, we can cancel out the h, because if you're dividing by h, that's really multiplying by the reciprocal. So once you pull the h out of the two terms you have remaining, dividing by h is really multiplying by the reciprocal of 1 over h. That's why those h's cancel. Dividing is multiplying by the reciprocal. Once you get that h to cancel, then you're pretty much good to go, because that was initially what was making the fraction undefined. So we have a negative 2x, a negative h, and then we have that x squared and x plus h quantity squared. So plugging a 0 in for h, plugging a 0 in for h means I have a negative 2x. And then what's left on the bottom? Darby? x to the fourth. Because you plug a 0 in here, so you have x squared, x plus 0, quantity squared, is another x squared. And when you have x's, if you have an x squared and a multiplying by an x squared, you add those exponents together. So x squared times x squared, adding the exponents makes x to the fourth. Finally, our derivative, make sure you use that fancy derivative notation. There's an x in the numerator, x to the fourth in the denominator. They reduce and give us -2 over x cubed. Questions? So algebraically, there's a lot going on. Getting a common denominator, remembering that the minus sign has to distribute to all of the numerator. Anytime you find a least common denominator, keep that least common denominator in factored form. Don't distribute it. It's easier to work with when it's factored. There's no reason to distribute it. Factored form is simplified form. And then we have those terms that are able to cancel out for us. So again, you're asked to find the derivative. Make sure you use that derivative notation. If you're asked to find the slope, you are still finding the derivative when you're finding the slope. Those two things are interchangeable. Questions on that? Are there any other questions that you've had? So again, 33 was similar to one of the problems from 799. Number 64. So 33 and 64, those two questions were pretty much the same function. 64 had g of x equals -4. So it's just equal to a number. It's a horizontal line. The slope of a horizontal line is 0. So the derivative is 0. All right, so if you want to head to Google Classroom, open up this review worksheet. And as I said, I just want to kind of go through a few things with you from the review worksheet. There we go. And the answers are provided for you. That last homework assignment on page 799, that was like the last page of the problems in the book. Like we really did get through pretty much most of the book. There were a few chapters that we skipped, but we skipped a chapter on vectors. We skipped a chapter on statistics, probability, which you kind of do in pre-algebra, algebra 1, algebra 2, geometry. Like you spiral that in. And of course you could take the prop stat class if you wanted to at this point. So we don't spend time reviewing probability and statistics again in this class. We just don't deem it as necessary as trying to get to the limits information. So on this worksheet, the first page, find the limits. So this is just limits. Remember, algebraically, factoring, common denominator, rationalizing. If the limit approaches a value for x, a numerical value for x, and you can't use direct substitution, factor, rationalize, find a common denominator. Those would be the algebraic methods to evaluate the limit. The bottom of this, actually kind of sprinkled through, it goes, some of them go to infinity, and those would be our rules as x approaches infinity. So if you see x approaching infinity, think of one of those 3 rules. Which one does it apply to? If you look at the next page, I want to start the problem at the very bottom of the next page with you, the next slide. So 15 asks you just to explain what that notation means. 16 is saying what's the definition of the derivative and graphically what does it mean. 17, use the definition of the derivative to find the derivative of those 2 problems. So that was like last night's homework. But looking at number 18, I want to graph the piecewise function so you have it graphed correctly. But then I want to look at the last two questions that has that notation that's a little different so that you understand what you're trying to find with that notation. So let's see if we can get this piecewise function graph. Number 18. Let's graph this piecewise function. 3 equations. The first one, f of x equals negative x. When x is less than -1 and x does not equal -2. I know that's a line. That line is decreasing. So just start off by graphing a line. Graph y equals -x. And let's see if we can then think about what the other stuff means. How does it apply to it? So we have 0 as our y-intercept, decreasing with a slope of -1. So there are 2 parts to then the restrictions on this function. It says x is less than -1 and x cannot equal -2. So I'm going to go to that part where it can't equal -2. And in my graph, where x is -2, I'm going to change that to an open circle. So if it can't equal -2, that means that point doesn't exist, just that point. And then the first part, x is less than -1. So I'm going to go to where it's -1. That's also an open circle because it says less than. So it's going to get really close to that point, but it's still going to be an open circle. Less than is left. So now I'm connecting to the left. So putting a little line in between those 2 open circles and then continuing to the left. So that first inequality, x is less than -1, open circle at -1, shaded to the left, but open circle also at -2. See, there's 2 open circles right next to each other. The second part says 5 when x is greater than 2. So again, think of that. That's really y equals 5. Y is equal to 5. If I go to where y is equal to 5, that is a horizontal line. X is greater than 2. So again, greater than means at the value of 2, we need an open circle. So open circle. Greater than would be right. Less than is left. Greater than then is the opposite direction and right. And we're going all the way to the right. So now I have 2 pieces of my function. The final piece would be x plus 2. So y-intercept is 2. Rise over run. Up 1 over 1, up 1 over 1. Or down 1, backwards 1. Now here's the part that I need to make sure. It says from -1 to +2, but it says less than or equal to it. So at -1, it's less than or equal to. It was an open circle, but now that point is part of this line at x plus 2. And because it's less than or equal to -1, that open circle becomes closed. So make sure that you have it now as a closed circle. I need to go all the way up to when x is 2. And again, it's less than or equal to 2. So here's where it's 2. That was an open circle, but now it's closed. Okay. Say it again.
Wouldn't it be below one of the open circles if it's +2?
It starts at +2, but then if I go in the opposite direction, I'm going down 1 over 1, so they connect right here. Because it has to start at the x value of -1.
How is the one at 2, 5 still?
It's,
It starts at 2, so it goes up on it goes to 2, 4, doesn't it?
did I miss a point? Oh, I see, right here. 1, 2, 3, 4, 5. Okay, so this guy here is open. And, oh yeah, I did miss that point right there. Okay. There we go. How's that? Is that what you were talking about? Thanks, Parker. I appreciate you catching that. So we have an open circle above it and a closed circle below. Thank you, Parker. Questions so far?
So there would be a question about the limit from a -1 approaching from the left side. Would we still say that it's reached, even though that one?
Yes, because once it's closed, like once it overlaps with a closed point, it is a closed point. Yeah. So A, B, and C, D all ask for the limit. E, F, and G all ask for the value of X. You need to find Y. But if you look at H and I, and this is hard because like the apostrophe almost looks like it blends right in with the F. But this says F apostrophe 0. And I says F apostrophe 3. How is E different than H? For E, which says F of -1, and H, which says F prime of 0. What's the question asking you to find in E versus what is it asking you to find in H? Peter?
E, it's asking when X is equal to -1, and then for F prime, it's asking like to find the derivative and then plug here in for your slope equation.
Yeah, so it's asking you to find the derivative, but the derivative really means find the slope. So you're finding the slope when X equals 0. That's what that really means. So the derivative is that F prime of X. Well, the derivative is also the slope. So find the slope when X is 0. This one, you're finding out Y when X is -1. So just kind of understand that notation. So when it's a derivative, you're finding the slope when X is that value. So go to the X value of 0. What's the slope of that line that it's connected to? Obviously, I can't display my little thing up here, but the last 3 questions, if you just look at that notation in 19 yet, and then I'll stop talking and I'll let you work. The notation, we have f of x equals x squared plus 3x. And then it says, find the equation of the tangent line at 1 f of 1. So the first thing you need to do is use the limit as h approaches 0. So f of x plus h minus f of x all over h. And then you need to find the actual slope by using the point. So find the slope by using the point. And then the last part, you need to get the equation of the line. Y equals mx plus b. So it's like 3 steps. This was like the problem I went over yesterday. It was number 47. So find the derivative, get the slope at the given point, but then find the equation of the actual tangent line. And the equation is going to be that y equals mx plus b form. So again, this is not due until Tuesday. So I suggested kind of working through 1 to 14, but maybe you want to do the last couple problems because I think that's what we are just going over. They're a little more involved. And then do the first group of problems later. But it's up to you how you want to work that. It is 9:20. So you have 12-ish minutes. We'll go over any questions that you have on Monday. Anything that you need re-explained, what's that question asking about? But please feel free to ask questions. Work with somebody, let me know if you need help. And you have books, did you put them in your book, Jeff? Just so I can have it on here.